I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. "12 formal architecture artifacts. That is what it takes to turn a vision into a working truth engine. I am Andreas Hamberger. This is the Hamberger Report, where I cover building an AI hallucination detection engine from concept to commercial product. In episode 1, we published the V.E.R.A project charter. Episode 2 laid down the 98 requirements that make AI stop lying. Episode 3 presented the architecture vision, the triple-layer verification system that mathematically separates predication from existence. Today we answer the question every enterprise architect asks after a vision is presented. How does it actually work as a business? Phase B of the TOGAF architecture development method is the business architecture. It is where vision becomes operating model, where principles become capabilities, capabilities become services, and services become processes you can test, measure, and deploy. For V.E.R.A, Phase B produced 12 formal architecture artifacts. This is the most comprehensive business architecture I have delivered in 30 years of enterprise architecture practice. Not because the subject demanded complexity for its own sake, because building a system that verifies truth requires you to be precise about absolutely everything. The 12 artifacts form an interlocking operating model, a requirements catalog, a capability model, a service catalog, a process architecture, a data model, interface specifications, an organization model, a test strategy, a gap analysis, a risk register, a forward-looking phase C and D architecture, and a master reference document that ties them all together. Every artifact is available on the V.E.R.A GitHub repository. We are building this in the open. The capability model answers a deceptively simple question. What does this system need to be able to do? Not how, not what technology. What fundamental abilities must it possess? V.E.R.A requires 6 level 1 capabilities. First, NTP logic processing, applying non-traditional predication theory rules to analyze and validate statements. Second, existence verification, checking that entities actually exist in a curated evidence corpus. Third, identity resolution, determining entity identity using 4 indiscernibility relations. Fourth, LLM integration, interfacing with large language models for natural language processing. Fifth, reasoning transparency, providing auditable, traceable reasoning chains for every output. And sixth, fail-safe governance, refusing invalid inferences and maintaining logical integrity at all times. These 6 capabilities decompose into 26 level 2 sub-capabilities. NTP logic processing alone breaks into 5. Formula parsing, existential loading analysis, consequence type classification, negation handling, and rule validation. Each maps directly to validated rules from Wessel, 1992. This is the critical difference between V.E.R.A and every other AI safety wrapper on the market. Our capabilities are not heuristics. They are not machine-learned patterns. They are formal mathematical operations derived from a peer-reviewed logical theory. You cannot convince V.E.R.A to skip a capability. The mathematics does not negotiate. From capabilities, we move to services. The V.E.R.A service catalog defines 8 business services. The flagship is the query verification service, the external-facing API that accepts natural language queries and returns NTP-validated responses, realizing all 6 level 1 capabilities in a single transaction. Behind it sit 7 internal services: existence lookup, identity resolution, crampits analysis, LLM wrapper, audit logging, refusal handling, and corpus synchronization. Each has designed service level targets. The crampits analysis service is designed to classify any formula in under 100 milliseconds. The existence lookup service targets sub 200 millisecond response times per entity check. When V.E.R.A goes into production, those targets become the basis for monitoring, alerting, and incident response. The process architecture is where V.E.R.A comes alive. It defines the exact sequence of operations that transforms a natural language query into a verified, ontologically sound response. The verification pipeline operates in 10 deterministic steps. Step 1. Natural language input receive. Step 2. The query parser converts it to an NTP formula. Pass failure triggers an immediate refusal. Step 3. Layer 1. The Crampits analyzer determines the existential loading of the formula. Is this claim asserting that something exists, or is it a logical pattern that stands on its own validity? Non-existential formulas skip directly to language generation. Step 4. For existential formulas, Layer 2 checks the e-corpus. Does this entity appear in verified evidence? If it does not, the system does not guess. It returns not_exists and refuses. Step 5. Layer 3 resolves identity using 4 indiscernibility relations. If identity is ambiguous, the output is qualified, not assumed. Steps 6 through 10 integrate the language model, intercept its output, post-verify every claim, and format a traceable response. If a claim cannot be verified at any stage, it is flagged or rejected. Notice the architecture. At every stage there is a gate. If the gate fails, the pipeline does not push through regardless. It refuses, qualifies, or escalates. This is the fail-safe refusal principle from our requirements implemented as process architecture. Integrity over answers, always. Every honest architecture includes a gap analysis. If you cannot describe what you do not have, you do not understand what you need to build. V.E.R.A has 15 identified gaps across 3 categories, 8 capability gaps, 3 knowledge gaps, and 4 infrastructure gaps. The capability gaps are the implementation roadmap in disguise. They tell us exactly what to build, in what order, across a 12-week sprint plan. The 3 knowledge gaps are worth calling out directly. They represent areas where our source materials remain incomplete. The hexadecagon structure, the formal definitions of strict versus lax consequence, and the detailed treatment of definite descriptions. All 3 require access to Wessel, 1989 or 1996, which we are actively seeking. We have marked these gaps clearly in the architecture. Intellectual honesty is not optional in a project about truth. The risk register identifies 16 risks. 3 are rated high. Risk 1, corpus completeness. No knowledge base is ever complete. V.E.R.A, a dot quote. S mitigation is the unknown response. When an entity is not found, the system does not assume non-existence. It returns unknown and qualifies the output. An honest I do not know is infinitely more valuable than a confident hallucination. Risk 2, prompt injection. Our defense is architectural, not heuristic. The NTP rules are enforced by deterministic code in the Crampits analyzer and the e-corpus verification service. You cannot talk your way past a mathematical proof. Risk 3, source material gaps. Our mitigation is discipline. The minimum viable product builds only on rules verified against Wessel, 1992. We build on what we have proven, not on what we hope to prove. All 12 Phase B artifacts, plus the Phase C and D architecture, are available at github.com/andreas-linux/V.E.R.A. If you are following the V.E.R.A journey, subscribe. I will share every step, from proof of concept to product. Subscribe to the Hamberger report, new videos every day. That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.